Hello viewers, welcome to my channel. I'm Hasham Ali Khan. Last two videos I have explained you about the assignment problems. Now in this video, practically we are going to do the problems on assignment. So actually assignment problems are those problems where we have limited resources. We have finite number of resources and finite number of activities. One resource has to be applied to one activity so that we achieve the objective. The objective may be minimization or maximization. Minimizing the cost, minimizing the distance or time, maximizing the sales or maximizing production or profit, these type of problems. And already I have explained you about the algorithm of solving assignment problem, Hungarian method. Actually, assignment problem can be solved either by linear programming method or by transportation method, but the simplest method was given by Hungarian mathematician D. Koenig. All these things I have already explained. So before starting the problem, I expect my viewers that already you have watched the theory videos. Without understanding the concept, I suggest you not to go directly for problems. So if you have not watched the earlier videos, I suggest you go to the playlist of my channel. Select the subject operations research. Select the videos of assignment problems. Be perfect about the theory, the algorithm particularly, then only you can understand the problems. So before starting the first problem, I expect my viewers to have a printout of the problems which I have given in the link under my description. Take the screenshot of the notes which I have written on the board, then I'll explain. Come on, see the first problem. A computer center has got 4 expert programmers. These are the resources. The center needs 4 application programs to be developed. This is the activity. The 4 programmers are there and 4 programs have to be developed. The head of the computer center, after studying carefully the programs to be developed, estimates the computer time in minutes by the respective experts to develop the application program as follows. Programmers are given in rows. First programmer, second programmer, third and fourth. And programs are given in the columns. A program, B program, C and D program. And the time estimates are given in minutes. For example, first programmer, if he is assigned A program, he will take 120 minutes. The same first programmer, if he is given B program, he will take 100 minutes. C 80 minutes and D 90 minutes. These are the time estimates which first programmer will take in order to make A program or B or C or D. Similarly, second programmer, if he is assigned A program, he will take 80 minutes, B 90 minutes, then 110, 70. These are the different time estimates of second programmer. Third programmer 110, 140, 120, 100. And last fourth programmer, he will take 90 minutes to complete A program and 90 minutes to complete B program, 80 minutes for C and 90 minutes for D. The different time estimates are given. Now we are concerned with which program should be given to which programmer. Explain how to assign the programs to different programmers. This is the assignment problem. Here you can see step. Already I have explained the algorithm of solving the linear assignment problems given by Hungarian mathematician. Now step 1. Subtracting the smallest element of each row from every element of the corresponding row, we get the following reduced matrix. Now see carefully. The first row, what is the smallest element in the first row? 80. So subtract 80 from all the other elements in that row. So 120 minus 80 is 40. Here I am writing 40. Then 100 minus 80, you will get 20. Then 80 minus 80, 0. 90 minus 80 is 10. First row completed. Second row, the minimum is 70. So 80 minus 70 is 10. Then next 90 minus 70 is 20. Next one is 110 minus 70 is 40. And 70 minus 70 is 0. Third row, minimum is 100. So 110 minus 100 is 10. Then 140 minus 100, 40. 120 minus 100, 20. 100 minus 100, 0. Last row, minimum is 80. So 90 minus 80, 10. Then 90 minus 80, 10. 80 minus 80, 0. 90 minus 80, 10. So first step completed, row subtraction. Now second step, subtracting the smallest element of each column. From every element of that column, we get the following reduced matrix. First step, row subtraction. Second step is column subtraction from this one, not from the original problem. From this. So what is the smallest in the first column? 10. Subtract 10. So 40 minus 10 is 30. Then 10 minus 10, 0, 0 and 0. Right? Second column, the minimum is 10. Subtract 10. 20 minus 10 is 10. Here 20 minus 10, 10. 40 minus 10, 30. 10 minus 10, 0. Now third row, third column, minimum is 0. So subtracting 0 means same values will get 0 minus 0 is 0. Then 40 minus 0 is 40. Then 20. Then 0. Last column again minimum is 0. So same values will come. 10, 0, 0 and 10. Two steps completed. First step row subtraction, second step column subtraction. Now third step, drawing minimum number of horizontal and vertical lines so as to cover up all the zeros. Now see here, the same values I am going to take 30, then 0, 0, 0. Next one 10, 10, 30 and 0. Third column is 0, 40, 20. 0, 40, 20, 0. Last column 10, 0, 0 and 10. The same values I have copied from table 2 to table 3. Now in table 3, draw the minimum number of lines so as to cover up all the zeros. Minimum lines. So maximum how many zeros we can cover up in a single line? 3 zeros are there in the first column or 3 zeros in the last row. So maximum 3 zeros we can cover up in a single line, either this column or this row, right? So what I am doing is this column I am drawing a line, vertical line. Now maximum how many zeros we can cover up? Here if we go this column, 2 zeros. If we go this row, 2 zeros. So 2 zeros we can cancel. This 2 zeros are cancelled. Here also 2 zeros are there. Like this, 2 zeros are cancelled. So lastly, only 1 zero is left. We can cover up this 1 zero either vertically or horizontally. Any way you can do, because we need minimum number of lines, vertical or horizontal. So I am taking vertical line. That's all. So now count how many lines are required to cover up all the zeros. 1, 2, 1, 2, 3 and 4. Number of lines are 4. And what is the order of the matrix? How many rows and how many columns? 4 by 4. 4 rows and 4 columns. The order of the matrix is 4. Now you can write, since the number of lines are equal to order of matrix, so optimum solution is reached. Optimum solution is reached. Whenever number of lines and the order of the matrix are same, then we reach the optimum solution. Now we have to assign. The optimum allocations are as follows. So copy down the same values: 30, 0, 0, 0. Next one is 10, 10, 30 and 0. Fourth column 0, 40, 20, 0, 40, 20, 0. Last 10, 0, 0, 10. All the values I have taken. Now, making the assignment means check whether in any row a single 0 is there. First row only one 0 is there, only one 0. So assign that 0, otherwise it will get cancelled. So 0 I have assigned. This is called assignment, putting the 0 in a box. Now cancel the other zeros in that column. In that column any other 0 is there, cancel it. This is cancellation. Now check any other row having a single 0. Second row we have 2 zeros, third row we have 2 zeros, and last row also 2 zeros. That means we have multiple solutions. In this problem we don't have a single solution, we'll have two solutions. Because here if we assign this 0, then what will happen? If we assign this 0, the other zeros in that column and row will get cancelled. This 0 will get cancelled, and this 0 also will get cancelled. Right? This 0 arbitrarily we have selected. We could have selected this 0 also. In the second solution, we will assign this 0. In the first solution, this is the assignment. The other 0 is cancelled in the row and column. Now check any other row having a single 0. Yes, third row only one assignment is there. And the last row also one assignment. Now you check all the zeros are either assigned or cancelled. First row 1 0 assigned, no other 0. Second row 1 0 assigned, no other 0. Third 1 0 assigned, fourth 1 0 assigned. We got the solution. Now optimum assignment. The first programmer should be given C. The first programmer should be given C, right? And second programmer should be given A. Then third programmer should be given D. And last fourth programmer should be given B. That's all. Now go to the original problem and find out the time estimates. First programmer C, how much time? 80 minutes. Second programmer A, 80 minutes. Third programmer D, that is 100 minutes. And last fourth programmer B, that is 90 minutes. That's all. So we have computed the total time estimates. Now we need the final total. So 80 plus 80 plus 100 plus 90. It comes to 350 minutes. That means if we assign these programs, then the total minimum time for completing all the 4 programs is 350 minutes. But here arbitrarily we have assigned this second. Now alternative solution will also exist and the same answer we will get. We'll check that one. An alternative solution of the above problem also exists as follows. When the alternative solution will exist, whenever we have 2 zeros in every row. Here we came across. So again same values I will copy. 30, 0, 0, 0. 10, 10, 30, 0. 0, 40, 20, 0. 10, 0, 0, 10. Same values I have copied. Now check any row having a single 0. Yes, first row single 0, assign this 0. Cancel the other zeros in that column. Row we don't have. Now 2 zeros are there. In the second row 2 zeros, third row 2 zeros, fourth row 2 zeros. Now arbitrarily we have assigned 2A. Now we are changing our decision. Instead of 2A, now I am assigning 2D. So cancel the other zeros in that column and also row. Right? Now see, here only 1 0 is left. In third row only 1 0. So assign this 1 0 and cancel the other zeros in that column. And lastly fourth again 1 0 is there. Assign this fourth 0. Now you can check all the rows will have either assigned 0 or cancelled 0. No blank 0 is there. So 0 here assigned, here 0 assigned, 0 assigned, 0 assigned. So first C. Second one is D. Second programmer D program. Third programmer A program. And fourth programmer B program. That's all. Now again go to the original problem and check the time estimates. First C 80. Second D 70. Third A 110. And fourth B 90. Again find out the total minimum time. We should get same total minimum time. Same we should get what we got the solution in the first 350 minutes. Check is it 350 or not. That is 80 plus 70 plus 110 plus 90 is equal to 350. We got 350 here. So first solution also 350, second solution also 350, but the assignments are different. It is called multiple optimum solution. That's all. This is the first problem I have completed. Now I am coming to the second problem. A departmental head has 4 subordinates and 4 tasks to be performed. So here 4 rows and 4 columns. The subordinate differ in efficiency and the task differ in the intrinsic difficulty. His estimate of the time each man would take to perform each task is given below in the matrix. Remember, whenever time is given, our objective is to minimize the time. Subordinates are A, B, C, D, 4 rows, and tasks are 1, 2, 3, 4. And the time estimates are given. How should the task be allocated to subordinates so as to minimize the total man hours? So all the values are given in hours, right? Now we need the first step. Subtracting the smallest element in each row from the corresponding element of that row. The reduced matrix is given. So here first row we can see 8, 26, 17, 11. Minimum is 8. So subtract 8. 8 minus 8. 0. Then next one is 26 minus 8. It comes to 18. Next comes 17 minus 8. 17 minus 8. You will get 9. Next one is 11 minus 8. 11 minus 8, 9, 10, 11, 3. Second row, minimum is 4. So 13 minus 4. 13 minus 4 is 9. Next one is 28 minus 4 is 24. 4 minus 4, 0. 26 minus 4, 22. That's all. Third row, minimum is 15. So 38 minus 15. 38 minus 15. It comes to 23. Then next comes 19 minus 15 is 4. Next comes 18 minus 15 is 3. 15 minus 15, 0. Last one is minimum 10. So 19 minus 10, 9. 26 minus 10, 16. 24 minus 10, 14. 10 minus 10, 0. So first row subtraction completed. Now I am coming to the second point, that is column subtraction. In each column we have to subtract. What is the minimum in the first column? 0. When we subtract 0, same values you will get to 0, 9, 23 and 9. Second column minimum is 4. So subtract 4. 18 minus 4 is 14. 24 minus 4, 20. 4 minus 4, 0. 16 minus 4, 12. Third column minimum is 0. So same values you will get 9, 0, 3, 14. Last column again 0 is the minimum. So 3, 22, 0, 0. That's all. So row subtraction completed, column subtraction completed. Now drawing minimum number of horizontal and vertical lines so as to cover up all the zeros. So same values you copied down in the third table. 0, 9, 23, 9, 14, 20, 0, 12, 9, 0, 3, 14. 3, 22, 0, 0. Same values from second table, I have taken it to the third table. Now drawing minimum number of lines so as to cover up all the zeros. See how many zeros we can cover up in a single line in any row or column. In the first column only 1 0, second column 1 0, third column 1 0, fourth column 2 zeros. If we go row wise, first row 1 0, 1 0, 2 zeros and 1 0. So what we are having is 2 zeros we can cancel either in this C row or last fourth column. Anyway you can do. So I will take the last fourth column, 2 zeros are cancelled. Now check any other row or column where we have 2 zeros. No. First row 1 0, second row 1 0, third row 1 0. Right? But last 0 is cancelled. We should not make this because 0 is cancelled means we don't have any allocation in the D. So we cannot make this, keep it same. 22 0 0. 22 0 0. We cannot cancel, we cannot draw this. If you draw that, all the zeros are cancelled. Now I'll make this 0. 2 zeros are cancelled. In one line, 2 zeros are cancelled. Now remaining 1, 2, 3. 3 zeros at 3 different locations. So what I can do? This one line and this 2 line and this 3 line. So how many lines are required? 1, 2, 3, 4. Number of lines are 4. Order of matrix is also 4. Therefore, optimum solution is reached. Optimum solution is reached because number of lines are equal to the order of the matrix. We have reached the optimum solution. Now allocations. How to give the allocations? First copy down 0, 9, 23, 9, 14, 20, 0, 12, 9, 0, 3, 14, 3, 22, 0 and 0. That's all. Same values I have copied. Now giving the assignment, we have to check any row having a single 0 that should be allocated first. First row we have only 1 0. So assign this 0 and cancel the other zeros in that column or row. We don't have any other 0 in the column and row. Now check any other row having a single 0. Yes, we have in the B row, only 1 0 is there in the B row. Assign that 0, cancel other zeros in that row and column. Check any other row having a single 0. Yes, D. D row we have a single 0. Assign this 0 and cancel the other 0. Any other row having a single 0. C. Only 1 0. We have not applied any arbitrary rule. Every time we are having 1 1 0 and we have assigned. So in this case we'll get only one solution. We don't have multiple optimum solutions, just like the previous problem, 2 solutions we got. Here only one solution we'll get because we have not used any arbitrary rule here. Now A1, optimum allocation A1, then B3, B it is 3, C it is 2, and last D it is 4. So we have made the assignment. Now we want the man-hours. For A1 it is 8 hours. For B3 it is 4 hours. Then C2 it is 19 hours. And last D4 is 10 hours. So total minimum time is equal to, now we have to add up 8 plus 4 plus 19 plus 10 is equal to 41 hours. 41 hours. So in this problem what you have seen that only one solution exists. Here 2 solutions exist because two zeros are there in every row. That's why we have arbitrarily assigned first 2A here, 2A here, and here we have assigned 2D here. That's why we got two solutions with the same answer 350. But here we'll get only one solution, right? So in this video, two problems I have explained regarding this assignment problems. So my suggestion to my students, practice these problems. Watch the video twice, thrice, and make your own calculations and check. Then only you can get the perfect knowledge on this topic of assignment. Simply watching the video once or listening the lecture is not at all sufficient. A lot of practice is required. So inshallah, we'll continue the next problem in the next video.